All right, so in section 15.6, we're doing triple integrals. And so when you do the triple integral of simply 1 right here, you end up getting the mass, or like the volume of a cube, and especially if you're going from 0 to 1, here, and all three pieces. So then when you put a function here, then what that function stands for is the density function of the object. So if you're thinking geometrically, so then you have a mass of a cube where the density is given by f of x, y, z. So the f of x, y, z is controlling the density of the object, and then you're still doing a cube. So, you know, it's kind of takes a different meaning than just a geometric meaning in a way. If we already went over, go ahead and skip to where we left off in class. If you are coming into this video and we already did some of it in class. All right, so this here is just more of Riemann sums and telling how now it's a triple integral. So basically things from before. Fubini's theorem is where you are saying that you can basically like switch these around, and if they're all numbers, it doesn't matter which order we do as long as we can integrate properly. So let's go ahead and try one here. So I have to integrate with respect to x first. So when I integrate x squared, I get x to the third over 3. And yz is just a constant to me, so it just gains an x. So I have to plug in x equals 0 to x equals 2. So I plug in a 2, I end up getting 8/3 plus 2yz. And when I plug in 0, I get 0, so that's gone. All right, whoops. So I have to two integrals to do, and then dy dz. So integrate with respect to y, I get 8/3 y, plus I get 2y squared over 2, so it's y squared, and then the z hangs on. This is going from y equals -3 to y equals 0. So I plug in 0, I get 0, minus when I plug in -3. So I plug in -3, I would get 8 plus 9z. So, yep, so sorry about that. So, something's wrong with my signs there. Hang on a second. This is supposed to be a -8, right? All right, because I'm plugging in a -3 right here. All right, so I end up getting that I have one integral left to do from -1 to 1. And I have 8 minus 9z. So that's a polynomial you can put in your calculator if you want. But we get 8z minus 9z squared over 2, evaluated from -1 to 1. This comes out to 16. All right, so this is just a bunch of rules about integrals, basic things. You have two things added. You can split it up into two separate triple integrals. You have a constant, you can pull it out front. One function is above another function, then your integral is going to be greater than that integral. And this guy, if you have something, a contained triple integral, you can break it up into two pieces if you need to. All right. So then we talked about how you have basically 6 orders of integration that you could have. And so realize when you do this that anything, your inner integral can contain at most 2 functions or 2 variables. So like if z is on the inside, then it can have x's and y's in the definition of these expressions here. Then if y is next, it's allowed to have x, and if x is last, then it can only have numbers here. So most important thing is that the innermost integral can have 2 variables, the middle one can have 1, and the last integral on the farthest outside can only have constants or, numbers. All right, so let's try to set this one up. So the worst part is coming up with like a picture, but this is one we did in class. We have this tetrahedron here, so this is a plane. It's crossing at 1, 1, and 1. So basically what's happening here is you have a plane coming down and cutting this area off, and so it's this tetrahedron that you're making right here. So it's that little triangular pyramid looking thing. All right, so we can just think to ourselves floor to ceiling. So I have my triple integrals. I'm going to do, basically I'm going to do my base to my ceiling, which is my plane right here. So I'm going to be doing 0 to 1 minus, solving for z, 1 minus x minus y. I have a z right here, so that's dz. Then we have to think of this line here. This is my x-axis and my y-axis. I'm going from 1 to 1, and so this line right there, that's this little triangular space down below. All right, so this is the line y equals 1 minus x. So that space, I'm going to do dy next, 0 to 1 minus x, and then finally dx. I'm going to go from 0 to 1 right here. All right, so time for to integrate. Let's see, so integrate with respect to z, I get z squared over 2. So I'm going to put the 1/2 out front, still have two integrals, and I have z squared to evaluate from 0 to 1 minus x minus y. So I'm going to plug 1 minus x minus y in there, so I have 1 minus x minus y squared, and then minus 0, so that doesn't do anything. All right, so I have 1/2, I still have a double integral to do with dy and dx. So you have two options at this point. You can take this and square it out. You can write it twice, multiply it out, and then it'd be 9 parts, and you would simplify it down a little bit. That would take a while, and it would be kind of like a long problem. So instead, let's go ahead and do some u substitution. So we're going to make u be this part here. So u is 1 minus x minus y. So then du, but with respect to y, remember, would be, derivative with respect to y would be -1 dy. So I'd have to put a -1 in my problem to make this substitution. So I have a -1/2 out front. I still have a double integral, but now I have u squared, and then du, and then the dx is still out there. So the integral of this part would be u to the third over 3. So I'm going to get a -1/6 out front right now. I'll put it up here. All right, and I have u to the third, so I basically have something to the third. I still have dx to do, but I still have to evaluate this. So u is 1 minus x minus y. To evaluate this from 0 to 1 minus x. So that means I have to plug in 1 minus x for y. So I would get 1 minus x minus 1 minus x to the third, minus plug in 0. So I'd get 1 minus x minus 0 to the third. So this piece up here cancels out. So I end up getting -1 minus x to the third. All right, and so I basically have that combined with my -1/6, so I have two negatives, makes a +1/6. So I get a +1/6 integral, and I have 1 minus x to the third still, dx. So you're welcome to put that in your calculator. You could also do some u substitution, 1 minus x, and then du would be -1 dx, and plug that in, integrate u to the third. But either way you do it, your final answer will be 1 over 24. In class today, 2021, I had said the answer was 4. I was looking at the wrong part of my paper. I was looking at the next problem. The answer is 4, and I should have been looking in this other place. So anyway, that's the answer. So make that fix, please. All right, so here. So the hard part with some of these is to come up with the limits of integration and think about like, how do I make this picture do what I want it to do? The easiest thing is to make z, like floor to ceiling, like we did on our worksheet, but sometimes that's not going to work out. So look at these problems here. So when I look at these pieces here, I have x is between these two things, y is between 0 and 2. So this right here is pretty suspicious. This is numbers. So I'm pretty sure I'm going to want to use my y on the end because that's contained between two numbers. All right, and then let's see about the rest. So let's get an idea of like what this looks like. So this guy, this is z equals 0 and z equals y. All right, so this is going to be a little bit hard to tell what's going on, x, y, z. So z equals y is a plane that's like coming off right between the z and the y axis, so like a 45-degree angle. So if I drew z and y, that plane is like that plane right here, like right between those two. So it's like right here, but it's like coming towards me, so I can't really draw it very well. All right. So y is staying between 0 and 2, so it's going to be cut off at 2 and 0 there. And then let's see what we have right here. So that's my x and my y axis. If I recreate this, x equals square root of 4 minus y squared. That's x squared equals 4 minus y squared. That's x squared plus y squared equals 4. So that's just a circle with radius 2. And it says that x is between x equals 0 and that circle. So it's between here and this circle. So it's really this part right there. But I want to stay when y is between 0 and 2. So frankly, it is just y equals 0 to y equals 2. And so it's just this little part right there. Okay. So I have that piece, and the ceiling of it is this z equals 0 and z equals y. All right. So we are going to start here. We are going to have y is going from 0 to 2 because that is definite numbers. So that's going to be my dy on the end. And I do have a 2x right here. All right, so that's going to be my last one. Now, for the inside. So I have this equation with x is between 0 and these two things. So I think that I'll put that next. All right, so x is from 0 to the square root of 4 minus y squared. All right, and then on the inside, that'll be my dx, and that just contains y, so that's fine. And my z, oh, well, I'll just go ahead and start with my z. Yeah, I should have done that all along, sorry. All right, so that'd be 0 to y. So that's fine. Here we go. So integrate with respect to z, so I get 2xz. I have to be z equals 0 to z equals the square root of 4 minus y squared. All right. Oh, I see why I didn't want to do this. So look what happens. If I plug 4 minus y squared in for the z, look how ugly that is. So I don't want to have this radical. That's why I wanted to do it differently. So I think what we'll do instead, so that's fine. So why don't we just go ahead and switch it, 0 to 2. It doesn't really matter, like if I switch these, the inner two, they both involve y's. They have 0 and y's. So I'm going to make this y right here in the square root of 4 minus y squared. And I still have a 2x. Because now we're going to make this dx and then dz and then dy. So that was a good mistake to make, actually. I'm glad I did. All right. So when I integrate this, I end up getting 2x squared over 2. Well, that's just x squared. And I'm evaluating this from x equals 0 to x equals 4 minus y squared. All right. And so that's great. I'm sorry, the square root of that. And so it squares away. So I end up getting 4 minus y squared minus 0. Right? Yeah. All right. So 4 minus y squared is left over. I still have two integrals to do, dz and dy. All right, so integrate this with respect to z, so it gains a z. 4 minus y squared. I'm doing z equals 0 to z equals y. So basically the 0 goes away, but the y comes out front. So I'm going to come over here, and so I'm going to have basically y times 4 minus y squared. And I still have one integral left to do, and it has a y, and so this is 0 to 2. Okay, so basically this is a polynomial, so I have 4y minus y to the third from 0 to 2 and dy. So put that in your calculator or you do it and it comes out to 4. Okay, so anyway, like I was saying, this maybe we could have done this problem, but this would have been like really gross to like plug into here. And actually it would have been okay, but it just would have been horrible. So it's much better to switch it over here. All right. So number 4, let's see. All right, so this picture, and I do have a little diagram that I'll show you in class and everything of this, but let's start here. So we have these parabolic cylinders right here. So if I draw z and x, z equals 3x squared is a parabolic cylinder pointing up, and z equals 4 minus x squared is a parabolic cylinder going down. Okay, crossing at 4. All right, so let's look at this guy right here. That is a plane, so I can draw that on the x, y, z. All right, it's touching at z equals 6 and y equals 6, okay, and coming across like that. Meanwhile, our shape over here, this guy, the parabolic cylinders we were drawing, remember that's going on the z and the x-axis. So let me draw that, coming back. So we have this shape down here. So let me see, I know this is tough, but this is crossing at 4, it's coming down, and then this other one is coming up. All right, so you have that like kind of tube that's getting created like right inside here. And then it's getting sliced off because that tube is going along the y direction forever. So it's like coming this way and going that way, but it's getting sliced off by this guy right here. Okay, so whatever you can make of that in your mind. So let's take a look at our integral here. Let's see. So my z values involve x's. My y involve 0 and z plus y equals 6. So let's see. How do I say this? So volumes, I'm putting a 1 right here. All right. So I think I'm going to decide to do x's from here to here. We'll figure out where those meet up right there. So I'm going to go from side to side. So it's going to be my last thing. So now we have to think to ourselves, what do we want to do next? So my z would involve a y, but with this guy right here, when we put those in the middle, all right, if I put those in the middle, then they just involve x's, and so then x is going to go from these two places here. So let's put z in the middle and then dy here. All right, so y. I'm going from y equals 0 out to this plane right here. So I'm going along the y-axis from 0 to this plane right here. So I'm going from y equals 0 to this plane, so that would be 6 minus z. All right, and then my z is going from bottom to top right here, so 3x squared to 4 minus x squared. And then my x's, I have to figure out where these are meeting. So I have to figure out where 3x squared equals 4 minus x squared. Well, move the x squared over. Get x squared equals 1, so that is at plus or minus 1. All right, so we're integrating 1 right there. So we have, we get y from 0 to 6 minus z. So I end up getting 6 minus z. I still have my two integrals with dz and dx. So with z, I end up getting a 6z minus z squared over 2. All right, I have to do this from z equals 3x squared to 4 minus x squared. All right, so 6 times 4 minus x squared minus 4 minus x squared over 2 minus, when I plug in 3x squared to 6z, I get 18x squared. And I'm still subtracting, but I have another minus right here, so that'll be a plus. Then I have 3x squared, so it'll be 9x to the 4th over 2. All right, and so I am still going to have to do my integral of this from -1 to 1, but polynomial, calculator, and go ahead and put this and I'll check it later. This is supposed to be, what, dx? Sorry. Put 304 over 15, and I'll check it out in class because in my notes here, I'm missing that 2 right there, and I wonder if I plugged it in my calculator correctly or not. I might not have. All right, so let's do this next one here. So let's see. We're not evaluating these last two, so it should be done real quick. All right, so a solid bounded by these things right here. So z equals 0, so that means we're going to be held up to the top of something. Z equals y. So again, that's that like weird like 45-degree angle plane. this guy, x squared equals 1 minus y. So that is y equals 1 minus x squared. So that is going to be a parabolic cylinder coming down. It's going to cross here and here. So look at what's happening here. I have a plane, remember, kind of coming out. And so I have this shape. This shape travels all along the z-axis. So this thing goes up and up and up, this parabolic cylinder. And so what's happening is I end up getting this kind of shape. It's here, there's a parabolic cylinder, and the plane is cutting it off. So we get like a taco, like a really strict taco with like a little flat bottom right here. And then like that taco shape kind of like opening up right here. Right, I can't draw. It's like right there. Okay. All right. But this is going out to 1 on the y-axis. So I think we can do good old dz first. So we'll do, we have our function. We can do dz. We can do 0 to y. And then all I have to do is contain my parabola. So my parabola, that parabola I have right there, I got this parabola, so I'll go ahead and do 0 to 1 minus x squared. And then we'll go ahead and go negative 1 to 1 for dx. Right, and we're not evaluating this. All right, this last one right here. So this figure, you're like, oh great, they gave me a picture. So don't forget this volume thing right here. You know, there's a 1 right there. We talked about that a lot already. This picture. So look at how this line comes out and then it's like crooked right there. And so that's because this picture is kind of deceiving. So you have to draw it yourself a little bit too. So you have a parabolic cylinder, this guy right here, coming down as your ceiling. So that's going to be our ceiling. We're going to make that our inner integral, 0 to 1 minus y squared. Okay, that's going to be dz. And we want volume, so a 1 right here. But the floor. So the floor right here, the xy plane. So we're going from x equals 3 minus y. This equation is also y equals 3 minus x. So it starts at 3 and goes down 1 over 1. It hits at 3. So you have that line right there. Now, this one back here. This is also y equals 1 minus x. So this starts at 1 and goes down 1 over 1, so it hits at 1. All right. So what's suspicious here, you see how that's crooked? That's because this little corner is missing. And also what happens is this is being cut off. The parabolic cylinder is coming down and cutting us off on the y-axis at 1. So what ends up happening is a parabolic cylinder is a ceiling. It cuts us off at y equals 1, so it's like cutting me off right here. So this is actually the bottom. This portion right here is actually the bottom of the shape. So that's the part that I have to contain with my x and y and all that. So I think I will go, I don't know, I'll just go side to side because they gave me those things real easy. So I will go, this guy over here is x equals 3 minus y. This one right here is x equals 1 minus y. So we'll do dx next. So 1 minus y down here and 3 minus y up there. All right, and then we just have to get our y values. And so that will be 0 and 1. And there we go. Do not do this bookwork down here. We were going to do some stuff with a worksheet and everything next